Welcome to the Altruistic Libertarian, advocate for a genuinely free society. I'm Anthony Wheeler, and today we begin a two-part case study of intervention with AT&T. Many decades ago, the government intervened in the market on behalf of AT&T. They supported a monopoly, the only way a monopoly can exist for any length of time in a free market, by preventing anyone else from providing telephone service in most of the country. In fact, all local telephone companies were granted such a monopoly, some of which still exist today. Having worked for AT&T from 1990 to 1997, I gained considerable insight into the nature of that monopoly and witnessed a large corporation struggle to reform into a competitive entity. The experience was instructive and worthy of detailed consideration. Classic AT&T was formed in 1984 after divestiture and ended in 2005 when it was purchased by SBC. SBC subsequently adopted the AT&T logo after subsuming the former behemoth. Prior to 1984, most telecommunications in the U.S. were a monopoly generally referred to as Ma Bell. In most cases, for most citizens, nobody else could provide telephone service in any form, up to and including inside wire and the actual telephone. This state of affairs began in 1913 after an agreement was made between AT&T and the U.S. federal government, one that allowed AT&T to operate as a monopoly until divestiture in 1984. Justification for this monopoly was provided by AT&T's executive leadership, and I quote, "One policy, one system, AT&T's, and universal service. No collection of separate companies could give the public the service that the Bell system could give," unquote. It is important to note that the only way a commercial entity can operate for any length of time as a monopoly, let alone for almost 7 decades, is through the complicity of the government, the actual regulations that prohibit private entities to enter the same market and operate. In 1984, divestiture broke up AT&T into 8 distinct entities. AT&T, the long-distance company, having retained Bell Labs and their traditional equipment manufacturer, later to break off and become Lucent in the 1990s, and 7 regional Bell operating companies, or RBOCs. Those 7 RBOCs were Ameritech, Bell Atlantic, Bell South, NYNEX, Pacific Telesis, Southwestern Bell, and US West. After 1984, the RBOCs retained the local monopoly while AT&T became a competitive long-distance company. Their largest rivals at the time were Sprint and MCI. With divestiture, the government created 2 artificial industries, local and long distance. The country was divided into arbitrary LATAs, that's local access transport area. Local service, by definition, was a call originating and terminating in the same LATA. For this class of calls, the local telephone company, usually an RBOC, although the country was full of tiny independent phone companies as well, provided all the network, billing, maintenance, and provisioning. Long distance service was any call that originated in one LATA and terminated in another. This was the case even when the 2 LATAs resided within the same local company's network. Note the example of the Texas LATAs, with Texas being entirely part of Southwestern Bell at the time. In all cases, the local company was required to hand off the call to the customer's chosen long-distance provider via a network connection. This was accomplished by applying a primary interexchange carrier code, or PIC code, to every local line. This code indicated which long-distance carrier the customer had chosen and told the network which network to send the call to. AT&T's PIC code was 288. That's AT&T on a telephone. MCI's was 222. Sprint's was 333. The long-distance carrier, usually AT&T, Sprint, or MCI, would provide the network between the 2 LATAs and then hand off the call to the receiving local provider. The originating and terminating portions of the connection were called access. The long-distance carrier paid both the originating and terminating provider access fees, rated by the minute. These costs, of course, were passed along to the customer, each call generating originating and terminating access costs, along with the cost of maintaining the long-distance network. Post-1984, the major negotiating issue between the RBox and AT&T was the cost of access. I know this firsthand, as my first assignment with AT&T in 1990 was monitoring the RBox performance and providing detailed information for the negotiating teams that were attempting to systematically reduce access charges and to improve RBox operational performance on behalf of AT&T customers. Incidentally, I was responsible for Southwestern Bell and Ameritech. For those who lived in the 50s, 60s, and 70s, they will recall how expensive long-distance calls could be. For example, and this from the internet, quote, you want to hit up the inflation calculator if you want context. For instance, in 1962, a $3 per minute call to the UK would cost $21.38 per minute in 2010 dollars. During weekdays in 1980, AT&T charged $2.17, $6 in today's money, for a 5-minute call from New York City to LA, unquote. The following chart shows a range of rates in 1997 for several long-distance carriers. At that time, a 15-minute call would cost $3.75. Over the course of a month, long-distance bills for individual consumers could easily reach $200 to $300. A large portion of this cost can be attributed to access charges that all long-distance carriers had to pay. Today, the distinction between local and long distance hardly exists, and few people pay per minute charges for long distance calls. As a distinct industry, long distance no longer exists in any meaningful form. More on why below. I joined AT&T in 1990 and worked for several years in the Network Services Division. At that time, AT&T was consolidating 7 regional operation centers into 2. One in Denver and the other in Conyers, Georgia. Each center had network management, provisioning, and maintenance responsibility across half the country, roughly divided by the Mississippi River. Sprint dropped their famous PIN in 1989, creating a sense of desperate urgency in AT&T. Ironically, Sprint's claim to providing superior service through all digital networks rested on the back of AT&T's finest technology, as AT&T was wholesaling network bandwidth to Sprint. To maintain voice quality, Sprint required all of their circuits they leased from AT&T to be digital. At that time, a good portion of AT&T's network was still analog, negatively impacting voice quality for most of AT&T's long-distance customers. Everything was rushed in AT&T to digitalize the entire network and reduce operating costs. When I arrived in Denver, the new operations center wasn't yet operational, so we crammed into an equipment building that housed a 4ESS switch, the mainstay of AT&T's network, the Network Management Center, or NOC, and all the technicians that provided maintenance and provisioning support across the entire western United States. The earthquake in San Francisco in 1989, the one that took place during the World Series, exacerbated the consolidation as the Western Operations Center in Oakland was damaged, and instead of doing repairs, AT&T simply moved their operations and people directly to Denver. It was a chaotic mess at best. It's important to note here that such drastic measures never would have occurred in the old AT&T, that is prior to 1984, where prices were regulated and assured, employment was permanent, and customers captive. A bumper sticker from that time read, and I quote, "Ma Bell, we don't care because we don't have to," unquote. In the telecom industry prior to 1984, advances in technology were very slow, with some central offices using the same step switches that were first implemented over 50 years earlier. The 4ESS, that is the number 4 electronic switching system, the primary toll switch, that is long distance, was first deployed in 1976, and while the central processor was upgraded every few years, the basic structure remained intact into the 2000s. In most cases, the switch took an entire floor of a large equipment building. During my time, there were about 125 AT&T 4ESSs operational in the U.S. To jump ahead, the capacity of those large switches can be accommodated today in a few racks in a modern data center. While I had several assignments in those first 5 years, my primary focus was nodal provisioning. This service included a direct connect T1 between an AT&T 4ESS and a customer PBX, That's a private branch exchange, essentially a local switch for the customer. At one time, I supervised agents performing routing and trunking translations in the 4ESS. These translations, essentially programming, provided the switch and the network with the information and structure necessary to originate and complete voice calls to that company's PBX. The T1 had a measly 1.544 megabits of capacity with 24 dedicated voice channels. In contrast, most broadband services today provide a minimum of 10 times that much bandwidth, and as I sit here, I am enjoying a total of 150 megabits on my fiber connection, roughly the same as an OC3, a private network capacity unheard of in the 90s, literally 100 times more than a T1. Later, I had national process responsibility for the entire service, including engineering, design, and implementation of the T1 facility between the AT&T switch and the customer premise. For any particular customer, this entailed developing a detailed design for the T1 and AT&T's network, including the DAX assignments as a digital cross-connects, T3 assignments, every T3 could accommodate up to 28 T1s, switch terminations, and local POP, that is point of presence interface. Because the local company had a monopoly on access, AT&T had to issue an ASR, that's an access service request, for the tail circuit, a T1 that spanned the distance between the POP, point of presence, where AT&T and the local company co-located, and the customer premise. Had the status quo in the industry been maintained, this type of service would likely be common today. But in 1996, the Telecom Act was passed by Congress, allowing the possibility to compete for local services. This proved to be the death knell for AT&T. Prior to 1996, and in anticipation of competing in the local market, AT&T established another business unit with the intent of entering the local market when it became legal for them to do so. I joined that new business unit in 1995, moving to headquarters in New Jersey, providing me a front row seat to the ensuing industrial failure. Over many decades, AT&T as an industrial organization had grown fat, top-heavy, slow, complacent, and inefficient. When the competitive gloves came off in 1984, AT&T struggled to make the adjustments necessary to succeed. Many reorganizations, massive layoffs, new systems developed with the intent to automate, all conducted within a corporate culture unfamiliar with the creativity and leanness necessary to implement complex and challenging solutions. For instance, the primary provisioning platform was designed to perform routing and trunking automatically, thereby eliminating the need for human intervention. Unfortunately, the system was developed and implemented without real-world understanding of the process, a common failure in major systems development, and actually required more staff hours to perform the same function. The agents I supervised had to interface with a system that wasn't designed for human interface. As a result, the system was difficult to learn, exceedingly slow, and prone to putting customers out of service. We called that system Topaz. Given the reduced staff based on false assumptions of increased productivity, the agents had difficulty keeping up with the workload, and due dates were rarely met. In addition, most of the technicians and clerical staff were unionized, making it extremely difficult to address performance or attitude issues, contributing to continuing poor performance. Seniority ruled in every way among the union workforce. During layoffs, the younger employees went first, with no regard to skills, attitude, performance, or value, thus bleeding the company of potential energy, creativity, and leadership. Many of the technicians who remained were bitter and unhappy, and generally unmotivated. They had been moved out of their home switching center, across the country to Denver or Conyers, to sit at a desk in front of a computer and work troubles. Prior to being moved, the technicians knew their central office back to front. They maintained manual tub files with rows of 3x5 cards with records of cross-connects and port assignments. When they received a network order, they had intimate knowledge of their equipment and frames and ensured the records remained accurate. This was crucial when shooting trouble, as improper information could easily lead to mistakes, ones that could impact network performance. For example, in the early 90s, AT&T suffered a major outage at Thomas Street in New York City. From Wikipedia, and I quote, "On September 17, 1991, management failure power equipment failure, and human error combined to completely disable AT&T's central office switch at 33 Thomas Street. As a result, over 5 million calls were blocked, and the FAA private lines were also interrupted, disrupting air traffic control to 398 airports serving most of the northeastern United States. Because the building was designed to be self-sufficient, AT&T had a load shed agreement with the electric utility where they would voluntarily switch from utility power to on-site generators on request. This was a routine procedure that had been performed successfully in the past, but on this occasion it went wrong. After switching power sources, standard procedure was to check all the equipment power supplies, known as DC plants, for problems. But due to scheduled training, the check was not performed, and one plant went on battery backup. The alarms were not detected until it was too late to maintain uninterrupted power. That's unquote. I recall walking into the NOC, the Network Operations Center, that day and seeing the board lit up in red. So many calls were blocked. All of the Thomas Street technicians were out at the time, ironically in a training session about the new power alarms. This event added to the frustration of career technicians, certain it never would have happened in the old days. And they're probably right. In addition to monitoring distant alarms, the technicians in the new operations center had to rely on accurate network databases, some of them so old nobody knew how to program them. TERCS, for instance, that stands for Trunks Integrated Record Keeping System, an operating system from Telcordia Technologies, originally developed by the Bell system during the late 70s. These databases were notoriously inaccurate, requiring significant rework and or double work to implement new service or new equipment. For example, at another telephone company I worked for, I knew engineers who would physically check every cross-connect and port assignment to ensure they were available before issuing the work order to the field. This entailed driving from one office to another, significantly increasing the time it took to engineer the installation of new equipment. They couldn't trust the inventory databases, and it took less time to do the manual checks than rework the design when the work orders were inevitably rejected by the field technicians when the technicians found one of the assignments already in use. At AT&T, the operational support system architecture was incredibly complex, given that new systems and databases were piggybacked on existing ones until the multitude of interfaces and protocols grew to unbelievably complex proportions. Even with the unhealthy corporate environment, the constant uncertainty, the high stress levels, the older technicians couldn't leave. They were bound with golden handcuffs, retirement benefits just a few years away, with no way to make their union-inflated wages elsewhere. This contributed to a frustrated and defensive technical workforce, a significant impediment to corporate success. Well, that concludes our show for today, and the first part of our case study of AT&T. In the next episode, we will finish it up. Until then, peace.